Okay, so let's give you guys some more practice. So differentiate this. Find dy by dx of this. Okay, so press pause and have a go. Okay, so visualize this as being one bubble multiplying another bubble here. So visualize this whole thing here as this here. So so when you have one thing multiplying another thing, you can actually break up the two. So it's like this, and then here visualize it as one bubble here multiplying another bubble here. So you can break this up even further because here you've got one thing multiplying another thing. So that means you can break this up into one thing. So that's this bit here, and then for this bit here, you can break it up like this. Okay, and then now hang on, let me think. So now you've got the natural log of e here. So that just these two will pretty much kill off each other, leaving you minus 2x. Okay, and then differentiate. Remember, this here is just a number. This here is a constant. It's a number that doesn't change. So when you differentiate it with respect to x, well, it's just a number here. So it's really nothing. Okay. And then this one here will become negative 2. Differentiate this. It will give you 1 over that thing here. But then you've got to differentiate the bubble here itself. So that then gives you minus sine 4x. But then here you put another bubble here, differentiate that will then give you 4. Okay, so now tidy everything up, it will then give you this. And then get a graph plotter, and then tidy this. Remember that sine of x, so sine of x, sine of x, this is cos of x. Remember tan is this thing here. Tan is sine x over cos of x. So here you've got, well, this whole thing here becomes 4 tan 4x. Okay, so now get yourself a graph plotter, plot it here. The red line here represents our original y, the blue line represents our derivative, and then just have a quick check. Here, looking at the red line, it's going uphill, 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 uphill. So the blue line should be in the positive realm. So it's in the positive, 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 and then there's a turning point. Looking at the red line, there's a turning point somewhere in here. Well, the turning point is right there, looking at the blue line, and so on. Use the graph to double check your answer. So here the graph gives us an indication that this is correct here. Okay, so next one here, differentiate this. So find dy by dx of this. So press pause and have a go. Okay, so to do this here, you've got one bubble over another bubble here. So you can break it up into this. Okay, and then when you're here, you can visualize this as being one bubble multiplying another. So you can break it up even further. So that will then give you this thing. So that this here is this thing here, and then this here is this thing here, and then now you now these two will kill off each other, leaving you 3x here. Okay, and now using now differentiate it. This is just a constant, so you can pretty much forget about this. Differentiate this will give you a 3. Differentiate this will be 1 over this thing here. That's 1 over this thing here, and then you've got to differentiate the bubble itself. That will give you this. Okay, and then this thing here gets multiplied to the top. That will then give you this, a minus and a minus here. It will give you a positive here. Okay, and then get a graph plotter, double check your answer. The red line was our original y, the blue line's a derivative. So looking at the red line, it should be going uphill, uphill. So the gradient should be positive all the time. The positive should be all the time here. Now it's getting really steep. Now looking at the blue line, is positive, 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 and then it's still positive, and it's getting really steep. So it does kind of make sense. What happens over here, don't know, maybe not in our domain. Okay, so maybe this is not in our domain, so we don't need to worry about this. Okay, so the graph gives us an indication that this gives us an indication that our derivative is correct. Okay.